Make this look a little bit better so you can see it. Get some darker black markers. Now, I'm going to make some t-tables. All right. And I put -1 into this table. Why not? So why can't I put -1 into that one? Because this one says you can only use X numbers that are what? Either 0 or what? Bigger. So I don't have permission to put a -1 into this one. Have I got a permission to put 0 in there? Yeah, it says it's going to equal 0. So if I put 0 in there, doesn't 2 come out? What else can I put in there? -4, 1, 12, what can I put in there? I can put 0 or anything what? Greater than 0. 1's great. If I put a 1 in there, what's going to come out? Cool. I can put a 10 in there. 22 come out. Is everybody with me? So what does this graph right here, y equals 2x plus 2? Graphs a line. But do you understand, I'm not graphing the whole line. So I've got 0, 2, and I've got 1, 4. I'm only graphing this part of the line because I don't have permission to have any negative x values on that green line. Is everybody okay? So you got to be careful what you're plugging in. You got to go with what it tells you can use. Now, on this one, I plug 0 in here, I plug 1 in here. Can I plug all those numbers back over here? What numbers am I supposed to be plugging in this one? Numbers that are what? Less than 0. So give me a number I can plug in. All right. If I plug a -1 in there, what's going to come out for my answer? What's 2 times a -1? -2 plus 1 more is going to be a what? -1. What else can I plug in there? -2. So what's 2 times a -2? -4 plus 1 is going to give me a negative what? 3. Now, this isn't exactly correct yet, but we're going to fix it. -1, -1. And then I've got -2, -3. Everybody good so far? So I got a ray and another ray. Now, here's the problem with what I did. I left some numbers off. What's the first number that's smaller than 0? What about -1/2? What about -0.0283? Is everybody with me? Do you see that I didn't use any x's between 0 and -1? That's a problem. So here's what I'm going to have to do. I'm going to have to fudge a little bit. I don't know the first number that's to the left of 0. Now, so I'm going to have to fudge. Here's what I mean by fudge. Where am I supposed to put 0? In the bottom one, the top one, or both? Where does it say I've only got permission to put 0? In the bottom. But here's what I'm going to do. I'm going to put 0 in this one with a little star next to it. Now that star notation means something to me. If I plug 0 in there, do you see that I get 1 back out? That tells me what to back the graph up to. In other words, is this point 0, 1 really on this graph? So I'm going to draw it as an open hole. Is everybody with me? And I'm going to back it up to that open hole. So there's a place where the graph splits. It's going to split at 0, right? You're going to put it in both pictures, but you're only going to put it as a darkened hole in one picture. the one where you're supposed to put it. You're going to put it as an open hole in the other so you know what to back it up to. So that's how you draw a split point. Is everybody okay? Now,
since the red line is like an open hole, that would like pass the line test, right?
that's right. So do you understand what Cole said? Is this a function? Yeah, because it passes one time, and even here it hits that point, but what does that mean? Is there anything really there? So it still just hits what? One time. So it does pass the vertical line test, so it is a function. Now, do those graphs connect? Not on that one, but I can make a piecewise function where they do connect. So just because it's piecewise doesn't mean there's always a gap. All right, let me tell you what I'm talking about. What if it had been this? Let's see. What if this graph had been this one? In other words, instead of being y is 2x plus 2, what if it had been y is x squared plus 1 instead? Everybody with me? Now, can I put 0 in this graph? Is that okay? Can 0 go in that piece? So if I put 0 in there, what's going to go in there? 0 what? 1. If I put a number bigger than 1, like 1, what's 1 squared plus 1 more going to get me? 2. If I put 2 in there, 2 squared is 4 plus 1 more is going to be what? 5. Now, what is this graph? A line? What's that graph? Parabola. But again, I'm not graphing the whole parabola. I'm just graphing what? Part of the parabola. So I've got 1, 2. I've got 2, 5. Now, do you see that open hole? What am I about to do with that open hole? I'm about to fill it in. It's not on the red graph, but it's on the green graph. So even though that's a piecewise function, do those pieces hook together? Yeah. So sometimes on a piecewise function, they'll hook together, and sometimes on a piecewise function, what? They won't hook together. That's going to vary from graph to graph. Okay? All right. Everything else on your homework, okay? All right, so what I want to do then is I want to kind of keep going on the trig review. So on your books on page 33, all right, look in your books on page 33. Trying to see if I can get this board cleaned up a little bit. I want to make sure you know what you have to know to be successful in here. All right, do you see that chart on the top of the page? It has the trig, the 6 basic trig words, so to speak, in terms of words and in terms of letters. You have to know both. So you got to know that sine of an angle is opposite over hypotenuse. You've got to know that secant of an angle is hypotenuse over adjacent. Everybody with me? Now, on a unit circle, we talked about this a little bit before, but on a unit circle, the center is the origin and the radius is 1. So if the radius is 1, what's that force that point to be? Is it 0, 1 or 1, 0? It's going to be 1, 0, isn't it? Don't you go to the right one? What's this point going to be? 0, 1. What's this point going to be? Negative 1, 0. What's that point down there going to be? 0, what? Negative 1. Now, in terms of variables, it says sine of theta is y over r. But what's your radius on the unit circle? We said the radius was what? 1. Well, what's y divided by 1? It's just what? Y. So last time we talked about, does sine depend on your x coordinate or your y coordinate? Sine just depends on your what? Y coordinate. What's cosine depend on? X. Tangent is sine over cosine. So tangent's going to be y over what? X. So if you understand that, and you know your two special triangles, you're good to go. With a couple of rules. On a 30, 60, 90, the side across from 30 is a 1, the side across from 60 is the square root of what? 3, and the hypotenuse is a 2. On a 45, 45, 90, the legs are 1 and the hypotenuse is the square root of what? 2. Is everybody with me? So you got to be careful. You got a square root of 2 somewhere, and a square root of 3 somewhere, and a square root of 2, and then just a 2, so you got to keep them straight. Now, last time we went over, you can do work in degrees, but your final answers must be in radians. If you give me your final answer in degrees, I'm going to count points off. Okay? Now, here's the deal. We went over last time things like this. What's the secant of pi over 3? Well, first of all, you got to be able to change pi over 3 to degrees probably, because you probably do think better in degrees. So pi radians is how many degrees we said last time? 180. So that's really asking you to find the secant of what degree? 60. Correct? Now, so I'm not on this triangle, I'm on this triangle. Now, what is secant in words? Look in your book if you don't know. What's secant in words? Hypotenuse over adjacent. What's my hypotenuse? 2. What's my adjacent side? 1. So 2 over 1 is what? 2. The secant of pi over 3 is 2. And that's the way you do everything in quadrant 1. In quadrant 1, it's going to flip you to this or this, and you're good. Now, what if you have this though? What if it asks you for the sine of just pi over 2? What degree measures pi over 2? 90. Does everybody see where we're getting 90? 180 divided by 2? You can't do a 90 from the triangle. You can't do a 0 from the triangle. You can't do a 180. No multiple of 90 can be done here. It's got to be done over here. Where's 90 degrees? Does that mean you're up here? All right. Does sine depend on X or Y? Y. What's your Y? 1. Now, what would the tangent of pi over 2 be? What's the tangent of 90? Is tangent sine over cosine or cosine over sine? It's sine over cosine, which is y over x. So that's what? What's 1 over 0? Undefined. All right, is everybody following me so far? Now, what happens when you're not in quadrant 1? If you're not in quadrant 1, then these 3 rules come into play that are going to be real important. If you're in quadrant 2, or 3, or 4, you got to find something called a reference angle. Okay? Now, how do you find reference angles? See if either of these markers will work. You find reference angles with these rules. In quadrant 2, your reference angle is 180 degrees minus your given angle. If you're in quadrant 3, your reference angle is your given angle minus 180. And if you're in quadrant 4, your reference angle is 360 degrees minus your given angle. So you need to learn those 3 rules. Now, here's what's going to happen. When I ask you to do something like this, what's the cotangent of 3 pi over 4? Well, the first thing you better decide is what angle measure that is. So you got your calculator, so find me what angle measure that is. 135. What quadrant am I in then?
2.
2. Everybody with me? Now, this answer has 2 parts to it. It's got an SIGN, like it's either positive or negative, and it's got a number. The SIGN comes from the quadrant you're in. And the number comes from the reference angle. And they're done separately. And if you don't want to make a mistake, you probably better do the SIGN first because you'll forget it. So here's what I mean. Does cotangent depend on X, Y, or both? Both, because you got to put X over Y. Okay, if you're in quadrant 2, isn't your first number negative?
Yes.
And what's your second number?
Positive.
So if you put your X over your Y, you're putting a negative over a positive. What's that make the final answer? So this answer is negative. Now, what if I had said the sine of 135? Well, sine would only have depended on X or Y. Why? What's Y right there? Then your answer would be positive. So the SIGN just depends on your what? Your quadrant. Now, how do you know what number to write next to it? That depends on your what? Okay, what quadrant are we in?
2.
2. So in quadrant 2, my reference angle is 180 degrees minus my given angle. Okay? 180 minus, what's my given angle? 135. So what's 180 minus 135?
45.
45. I need the cotangent of 45. All right, here's 45. What's cotangent in words? Cosine over sine. So that's adjacent over what? Opposite. What's 1 over 1? So what's my answer?
-1.
Okay. What's the secant? All right, let's do this one. 11 pi over, let's do this. 11 pi over 6. All right, go find me that angle measure.
330.
330. Does everybody see where Connor got 330? We good? What quadrant are we in if we're at 330 degrees? Everybody see we're in quadrant 4? All right. What is secant the reciprocal of?
9. Cosine.
Cosine.
Some cosine, my bad.
All right. So is cosine X or Y?
X.
It's just X. So my SIGN depends on my X. If I'm in quadrant 4, what's my X coordinate? Positive or negative?
Positive.
Positive. Everybody understand? If you're in quadrant 4, you go to the right and then you go down. So that means this answer is gonna be what? Positive. Now, how do I know what number to write? I've got to find my what again? My reference angle. But my rule's different. If I'm in quadrant 4, what's my reference angle? It's what? 360 minus, now what's my given angle? 330. So what's my reference angle this time? 30. So I need the secant of 30. Okay, find 30. Here's 30. What's secant in words? Hypotenuse over what? Adjacent. So that's what you do when you're not in quadrant 1. Now, here's the advantage that's beautiful. This is the reason, one of the reasons we really like radian degrees. What was my reference angle right here? What's pi divided by 4? 45. Look over here. What's pi divided by 6? 30. Isn't that sweet? So radians make the reference angle super easy to see. Now, still you know what quadrant though, so I can know if it's positive or what, or negative. But it's a way to double check yourself and make sure your reference angle is correct. All right, we okay? Now, all right, that's if they give you, now notice what I'm doing here. I'm giving you the angle and I'm wanting the answer. Everybody clear? Because I'm about to flip it on you, like on the review sheet. What if I give you the answer and I want the angle? All right, so what if I were to do this? You had something, I don't remember what the exact problem was, but something on your review sheet like this. Sine of theta was 1/2 or something, or cosine of theta was a -1, right?
Sine of theta equals -1/2.
Equals -1/2, is that what it was? All right, let's do that one. Now, first of all, I want to ask you something. Does sine depend on x or y? Y. This says that the value is negative. So what quadrants must you be in if y is negative? 3 or 4, right? I mean, if y is negative, you have to be down here. So that's quadrant 3 and quadrant what? So you got 2 answers. You've got a quadrant 3 answer, and you've got a quadrant 4 answer. Now, again, how did I know that? The quadrant tells you the sign, so the sign tells you the quadrant. Now, what is sign in words? Like what over what? Opposite over what? Hypotenuse. Then build the triangle. Okay? Now, if habit, I usually put my angle in the left corner, but you don't have to. You can put it up there if you prefer. So do you understand that my hypotenuse must be a what? A 2. And my opposite must be a 1, not a -1. Is everybody with me? The negatives are telling me the quadrant. So my opposite must be a 1. Because sine is opposite over what? Hypotenuse. Now, I've got a right triangle. I know 2 sides. I don't know the third side. How can you always find the missing side on a right triangle? What do we call that? What's a squared plus b squared equals c squared called? Pythagorean theorem. So you got a leg squared plus a leg squared equals your hypotenuse squared. What is this 1? Is it a leg or hypotenuse? It's a what? Leg. Do I know the other leg? But I know hypotenuse is what?
2.
So 1 plus b squared is 4. So b squared is what? 3. So b is either a positive or negative what? Square root of 3, isn't it? Now, can a length be negative? And all of a sudden I go, oh my goodness, I know that triangle. What triangle has those lengths on it? A 30, 60, 90, but I got to know whether this angle's 30 or 60. Which one's across from the 1?
30.
The 30. Now, is 30 degrees one of my answers? Two big reasons. One is what quadrant's 30 in?
1.
1. I need it in quadrant what?
3.
3 or 4. And also I can't write answers in degree. That's my reference angle. So if I was in quadrant 1, 30 degrees would be legit if I changed to radians. But I need an angle in quadrant what?
3.
I'm back to these rules. All right, here's my quadrant 3 rule. In quadrant 3, my reference angle is my given angle minus what? Now before I knew the given and I was looking for the reference. What do I know this time? I know the reference and I'm looking for the given. So my reference angle was what, 30? So that's I don't know what my given angle is, minus what? 180. So what's x? 210. Now let me show you something. So this one is 210 degrees. Now I'm going to change these in just a second. How would I get my quadrant 4 angle? Well, now I don't use this rule, I use what? This rule, right? So now my reference angle, 30, is 360 minus something. So solve that for x. X is going to be 360 plus or minus 30? Minus 30. So what's my quadrant 4 angle? 330. Is everybody with me so far? Now, remind me again what my reference angle was. All right, my reference angle was 30 degrees. Now, these special triangles of 30, 60, and 90, 30, 60, and 45. They're always going to be 180 divided by something. Most of the time, you just kind of memorize them. But if you don't, how can you figure out what you divide 180 by to get 30? How can I figure out that missing number? All right, do a simpler one. 5 is 15 divided by something. What? 3. What's 15 divided by 5? 3. How am I going to figure this out? Okay, you got to calculate what's 180 divided by 30. What was it? 6. Well, what did I tell you 180 degrees was? So 30 is just pi over 6. We good there? Now here's the beauty. Do you see these other angles? They're always going to be your reference angle times a number. So 210 is going to be something times 30. What do you multiply 30 by to get 210? Don't you do 7? So that question mark's a 7, isn't it? What did you just tell me 30 was? Pi over what? Pi over 6. So do you see I get 7 pi over what? And that mean over 1? So I get 7 pi over what? 6. Same thing here. 330 has to be something times 30. All right, you got a calculator, figure it out. What do you multiply 30 by to get 330? 11. Well, what did you just tell me that 30 was? It was what?
5 or 6.
5 or 6. So what's 11 times 5 over 6?
11 pi over 6.
11 pi over 6. There's my two angles. So sometimes I'm going to give you the angle and you get me the trig answers, what you think about. Depends on two things. The quadrant tells you whether the answer is positive or negative, and your reference angle tells you what the number part is. The reverse of that is still doing the same thing backwards. In that case, you plug in the given and find your reference. Instead, when I switch it on you and I give you what you think of as the answer and want the angle, instead of plugging in the given and finding the reference, you're plugging in the what? Reference and finding the given. And the way you know what quadrants you are, remember your quadrants simply depends on whether this is positive or negative. The positive or negative depends on the quadrant. So you're either going this direction or you're turning around and going back the other direction. But both times the sign, the SIGN sign, SIGN depends on the quadrant and the quadrant depends on the sign. The number depends on the given and the reference angles. So you've got to learn these three rules. Everybody okay? All right. Now, if I remember right, there was something like this on your review sheet. Wasn't it? Now, what if the problem had been this? Can you work this problem? Then you can work that problem. How do you work this problem? What would you do first? Pull out a what? Not a 2, but a what? An x. What's that going to leave me right here?
2x.
A 2x minus a what? 1. So this says that one number times another number is 0, right? So either the first number is 0 or the second number is 0. So this one's already solved. On this one, I have 2x is 1, so what would x be? 1 what?
-1.
Oh, but when I moved it over, it'd be positive though, wouldn't it?
Yeah.
So I'd get 2 answers. We agree? This is the same thing. Only I've not factored out x. What do those two have in common?
Sine.
Sine theta. So what do you multiply sine theta by to get 2 sine theta squared? All right, first of all, do we know that this means this? Right? Instead of writing sine theta squared, they write it this way most of the time. But those are interchangeable. So do you understand? I have a sine theta squared. So what do you multiply sine theta by to get this right here? First of all, you're going to need a what? 2, aren't you? And then you need another what? Sine theta. What do you multiply sine theta by to keep it sine theta? So again, this says that one thing times another thing is 0. So what does that mean? It means either the first thing is what? 0, or it means the second thing is what? 0. So over here, this would mean if you added 1 to both sides, wouldn't 2 sine theta equal 1? How would I get rid of that 2? So what's sine theta? 1/2. Now we're back to where we just started. Does this say the sine of some angle is 1/2? And it wants to know what angle. Well, before, did we say sine depended on y? But this time y is not negative. What's y? Y is positive. So what quadrants am I in now? 2 or 1. So this one's got a quadrant 1 answer, and this one's got a quadrant 2 answer. And again, I would build my triangle. Remind me what sine is in words. Opposite over what? So the opposite would be 2, that would be 3. Pythagorean theorem would tell me that's the square root of 3 again, wouldn't it? In your angle across from 1. So again, it just so happens, what's this reference angle going to be? 30 again. And if I'm in quadrant 1, my answer is that reference angle, right? But instead of writing 30 degrees, again, we're going to write pi over what? Now, you go find me the quadrant 2. What was my rule for quadrant 2? Do you remember? What was your reference angle? 180 minus your given angle. So go find me your angle in quadrant 2, your given angle. And, you know, I know my reference is 30. So what do you subtract from 180 to get 30? 150? Now again, I can't put 150, right? But 150 has to be some number times that 30, doesn't it? 5. What did we say 30 was? Pi over what?
6.
There we go, 5 or 6. Now, y is 0. Am I going to get that off of a triangle? Where's that going to have to come off of? Unit circle. Now remember, this was 1, 0, wasn't it? That was 0, 1. That was negative 1, 0, and that was 0, what? Okay. Where are the y's 0?
On the x-axis.
On the x-axis. So this one and what? That one. Now, let me warn you about something. 0. I don't put 180. What do I put? Pi. Could I go 2 pi?
Yes.
Could I keep going and go 3 pi, 4 pi? You see what I'm saying? That's why the directions were important. Because I don't remember exactly what they were, but I said something like theta is an element of, and it was something like 0 to 2 pi, and 1 was a parenthesis and 1 was a bracket, if I remember.
That's exactly what it is.
So does the bracket mean included or don't include it? What's a parenthesis mean? Don't. So what the reason I told you this was so you wouldn't have an infinite number of answers. Otherwise, you just keep going and going. This says go around the circle 1 time. Go from 0 to 360 degrees. Include 0 and don't include what? So should I have 2 pi written down there? No, because of that parenthesis. Now, if it had been a bracket, I'd have had to have the 2 pi. So I got these 2 answers, or I got these 2 answers. Okay? Everybody good so far? All right, now, so on page 33 in your books, do you understand that you've got to know that box at the top where it says definition of the 6 trig functions? All right, look at the bottom box. I expect you to know those 3 Pythagorean identities.
Do you have to remember all these?
Yes. Not all, I'm telling you right now what you have to remember. So step 1, do you see the top box where it says definition of 6 trigonometric functions? You got to know that box. Okay. Do you see the bottom box? Okay. Do you see where it says Pythagorean identities? You have to know those 3. All right, down at the bottom, do you see where it says reciprocal identities? You have to know those three. In other words, you have to know that secant is 1 over cosines. Everybody with me? Then do you see where it says quotient identities? The tangent sine over cosine and cotangent's cosine over sine, you have to know those two. That's what you have to know out of that bottom one. Now, we'll get to a few more of those other things, but not for right now. Now, I expect you to know the basic shapes, all right, of a trig function without your calculator. What does sine and cosine look like when you're graphing them? They do that wavy thing, don't they? All right, you know what tangent and cotangent look like? You get some S-curves. Sometimes they go this way, sometimes they go that way, and then you got some asymptotes. Secant and cosecant kind of look like U's. Now, let me show you 1,000 years ago, when I didn't own a graphing calculator, how I graphed things. All I used was that unit circle that I just showed you. What was that point again over here? 1, what? 0. What was this one up here? 0, 1. What was this one? And 0, what? Okay, so watch. If somebody told me to graph sine, I'm going to go up by 90 degrees. So that's 90. That's 180. That's 270. And that's 360. This would be a negative 90. This would be a negative 180. This would be a negative 270, and this would be a negative 360. So the x-axis normally goes up by 90-degree increments on a standard one. And the y-axis goes up by ones. I'm going to kind of exaggerate it. So look why graphing them so super simple. If I'm graphing y equals sine x, does sine depend on x or y? Does it depend on y? All right, it's 0, what's your y? What is it? 0. At 90 degrees, what's your y? 1. At 180 degrees, what's your y? At 207 degrees, what's your y? At 360, what's your y? Now, go the other direction. If you go, instead of going counterclockwise, if you go clockwise, aren't the angles negative? So if I go to a negative 90 degrees, what's my y? What is it?
-1.
What if I go to a negative 180? What is it? 0. What if I go to a negative 270? What is it? 1. And if I go to a negative 360, I'm back to what? I just do that forever. Now, when you start putting numbers in front, it changes how high and low those hills and valleys get. Because if I had a 3 right here, instead of wavering between -1 and 1, it would waver between -3 and 3. That's called the amplitude. Now, instead of putting the 3 here, if I put the 3 here, it makes it either way faster or slower. So if you don't have your graphers, now on your graphers, if you do zoom, hit zoom on your calculator. Do you see what 7 says? What does Zoom say? What does the 7 option say?
Trig.
Trig. If you graph in Trig, that's the quickest way to graph it. Type in like y equals sine x, and instead of doing the window by hand, if you do Zoom 7, it does this window. That means every little tick mark on the x-axis is 90 degrees, and every tick mark on the y-axis is a 1. That's just quicker than going in your window and setting it by hand. All right. That's my review of Trig. Okay? Now, what we're going to do for the next 15 minutes is we're going to do inverse functions. Now, what we're going to do next week is we're going to do inverse trig. Won't that be super fun? Okay. So you can't do trig backwards if you can't do it forward. So tonight for homework, you're going to have some problems on inverse functions, just not trig, just inverse functions out of your book. And you have a few trig problems, but I'm going to put a trig worksheet on Moodle to give you some more practice with just plain old trig. Okay? So we're going to do inverse algebraic functions first. So you're going to do some trig and some algebra, and then next week we'll put them both together. All right. Now, there's a definition in your book. Let's see where they state it. All right, they put it on page 41. All right, here's basically what it says. F of x and g of x are inverse functions if f composed with g of x equals x and g composed with f of x equals x. Now you write that down and I'll show you what I mean. Here's what I want to know. I want to know if this function and this function are inverses or not. And on a test, you can't just go, yes. Or, I've got to see you check both of these. So do you understand that you're doing the composition both ways? So I'm putting G inside of F, and then I'm putting F inside of what? G. We did that last time, remember? Composition. So look what I'm doing. If I do F composed with G of X, am I putting G into F or F into G? I'm putting G into what? F. Okay, then you help me. What's the G? What's my G of X over there? It's what? The cube root of what? X plus 1 over 2. So all I did was replace G of X with what it was, correct? Now, if I had F of 6, what would that mean for you to do? Take 6 and put it in place of what? X, right? So what does it mean when I've got F at this red thing? What am I going to replace X with? That thing, right? So I've got a 2. Now what am I about to take this X out and put what in place of it? That thing right there, right? So I've got the cube root of X plus 1 over 2. But what have I got to do to it according to this? I've got to what? Cube it and then subtract what? 1. Do we agree? All right. What happens when you cube a cube root? Goes away, doesn't it? So that's going to leave me just what? X plus 1 over 2, isn't it? What's going to happen to those 2's? Aren't they going to divide out? So that's going to leave me x plus 1 what? What's that answer? Did f of g of x equal x? Check. And I've got to check it the other way, right? I've got to check g at f of x. So this time I'm putting f in what? G. All right. What's my f? Remind me what my f was. My f was what? 2x cubed minus 1. So what does that mean to do? It means to go to the g function. Isn't that the g function? What are you going to put in place of x? 2x cubed what? Minus 1. All right, so the cube root. So what am I about to put in place of that? 2x cubed what? Minus 1. But I've still got to put what? Plus 1, and it's all got to be over what? 2. What happens to those 1's? 2x cubed minus 1 plus 1. What happens to those 1's? Don't they go out?
Yeah.
So that leaves me the cube root of 2x cubed over what? 2. What happens to the 2's? Don't they go away? Which leaves me the cube root of x cubed. What's that?
X.
So did this equal x? Are these two graphs inverses of each other? Yes. What if just one worked? The answer would be what? No. What if neither one of them worked? The answer would be what? No. Now, I made this assumption one time and I won't ever make it a second time. Do you see that the variables here are x's? That's why you get x. What if the variable were z's? What would you get? Z. If the variables were t's, then you'd get a what? A t. It just means that you get the independent variable. Because on a test one time, I gave it in a different letter, like z, and the student put no, and I said, why do you, he obviously got z and z. And I said, why'd you write no? And he said, you had to get x and x. You're like, oh my word. No. I meant you had to get the independent variable. Okay? Now, what if I change the question to this? So one question I might ask you is I might give you two functions and ask you, are they inverses? So if I ask you, are they inverses, you do this to see what you get, and you do that to see what you get. And you just got to get the independent variable. The other thing they're going to ask you to do sometimes is this. They're going to ask you to do this. Find the inverse of, and they're going to give you some function, like f of x is x cubed minus 1. If it exists. Now, let me tell you this statement. It's helpful for a lot of people. When two functions are inverses, their domain and ranges switch. I mean. Suppose one function was this set of points, 2, 3, 4, 6, and -1, 7. That's the whole set of, that's their whole function, just 3 points. What if G was the inverse of this one? Instead of the point 2, 3 being on this one, what's going to be on this one? 3, 2. Instead of 4, 6 being on this one, what's going to be on this one? 6, 4. Instead of -1, 7 being on this one, what's going to be on this one? 7, -1. This would be the inverse function of that. So the domain and ranges do what? They flop. Now, let me ask you this. Instead of this being the point -1, 7, what if this had been the point -1, 3? Is that still a function? Can you repeat the y's on a function? Doesn't the function say for every x there's only one y? So 2 went in, how many numbers came out? 1. 4 went in, how many numbers came out? -1 went in, how many numbers came out? This is a what? Function. Is it a one-to-one function? No, it's a function, but it's not what? That's a shortcut way of saying one-to-one. Now, what happens when I reverse here? What is this one gonna be? 3 what? Anybody see a problem? This one what? It's not a function. All functions don't have inverses. Only one-to-one functions have inverses. So if I tell you to find the inverse, your first step is must have a one-to-one function. Because if the function's not one-to-one, when you do the inverse of it, because it's not a function. It can't be an inverse function if it's not a function. Okay? The easiest way to see if this function's one-to-one when you don't have the listing of the points is to look at the graph. How do you tell by looking at a graph if a function's one-to-one? How many tests they gotta pass? 2. What's 1?
Horizontal.
Vertical test. What's the other that's gotta pass? Horizontal. So on this one, the graph would look like that. Passes the vertical test, and it passes the horizontal test. So then I would keep going. Now, what if I had said this was your function? X squared minus 1. Is that function one-to-one? What?
Yeah.
It passes the vertical, so it's a function, but does it pass the horizontal? No, so is it one-to-one? Then you would stop and say, there is no inverse. End of story. So don't go hunting for treasure if there's not any. If you don't check, I'm gonna get you on a test. Everybody with me? So if it's one-to-one, then here's what you do. You solve for x, and then you switch x and y. So let's go back to the one we had. F of x is x cubed minus 1. Now, what's f? I don't see y. Where's y? What's the same thing as y? So if you just change it to y, if it makes it easier for you. So I would take my grapher and graph it. And we agreed it's 1-to-1, it's that S curve, right? So do I keep going or do I write no inverse? I what? I keep going. So what's it telling me to do if I keep going? I solve for what? X. All right, solve for X. What's X cubed gonna be? Y plus 1. So what's X gonna be? How do you get rid of that cube? You take the one to both sides? The cube root. So I'm on the cube root of X cubed is just X. And then I end up with the cube root of what? Y plus 1. That's what I mean by solve for X. What's my last step? To switch what? So instead of it being the cube root of Y plus 1, it's the cube root of what? Equals what? If it bothers you, you can write it. Can you say Y is the cube root of X plus 1? I mean, in addition to needed, so it doesn't matter, even equals the same thing. So this function and this function are inverses. Now, what the back of the book does is this, to emphasize that this one is the inverse of that one, they'll write it like this. I don't care, but that's the way the back of the book's gonna write. They're saying that the cube root of X plus 1 is the inverse of F. Because you might have like an F function and a G function and the different functions. Now, this is a little confusing. That's not true. Do you see that this -1 is up here? It's not this. All right? And the reason that bothers people is because X to the -1 is 1 over what? X. But when the -1's written, that's their notation for inverse. Is everybody with me? So where's your homework gonna be? I'll move it. All right, I will see y'all next time. Please help. Come see me if you need any help.